Okay, Pre-Calc, today we're going to talk about vector projections. This one's going to be a little bit more tricky, so just stick with me. Okay, given two vectors, v and w, it's useful to create a third vector known as the vector projection of v onto w. And the way we write that is the projection of v onto w. Okay, that's how it's going to be written. To find this vector, v is decomposed into w1 and w2 so that w2 is perpendicular to w and the projection of v onto w, projection wv is w1. All right, so here's two examples. You have two pictures there. Figure 1 shows the projection of v onto w when theta is acute. The angle between v and w is acute right here. So we're going to take W1 and W2 so that W2 is perpendicular to W. So here's W. So there's W2, that's perpendicular. And here's W1. V is decomposed into these perpendicular vectors. We talked about that in the other chapter or the other section. And this W1 is the projection of V onto W. Over here, when theta is obtuse, then our W1 is going to look like this, or our W2. And our W1 is going to be right here. Okay, we're going to have a formula for this, and it's going to make more sense. So the way we're going to find it is the projection, sorry about that, is the projection of V onto W equals the dot product of V and W over the magnitude of W squared divided by W. So let's look at all of these pieces. Dot product is a number. Magnitude squared is a number. W is a vector. So this answer is going to be a vector. Your answer is going to be a vector, right? So let's look at how you're going to do this. Number 1, V equals -4, -8, and W equals 3, 1. So we're going to find the projection of V onto W. So we got to find all these parts. We got to find the dot product, and that equals -12 plus -8, which is -20. And then we have to find the magnitude of W, which is the square root of 9 plus 1, which is the square root of 10. Now here, you don't ever need to simplify this. The square root of 10 doesn't simplify, but if it does, don't even worry about it, because look, we're going to square it, so the square root is going to go away. So the projection of V onto W is -20 over the square root of 10 squared times the vector W. Okay, this right here is just a number. What does that reduce to? It's -20 over 10, which is -2. So this becomes -2 times the vector 3, 1, which is -6, -2, and that is your answer. Your answer is a vector. All right, let's look at number 2. V equals -7, -9, and W equals 9, -3. Okay, we got to find the projection. So we need to find the dot product, which is going to be negative 63 plus 27, which is negative 36. Is that right? And then we have to find the magnitude of W, which is the square root of 81 plus 9, which is the square root of 90. So our projection of V onto W is negative 36 over the square root of 90 squared. See why you don't ever want to reduce that? Because you're just going to square it. Times W. So what does this reduce to? Negative 36. Negative 36 over 90 reduces to negative 2/5. So this is negative 2/5 times our vector, and that equals negative 18/5. And sorry about that. Where did it go? It went away. I think I erased it. Anyway, that equaled negative 2/5 times our vector 9, negative 3, which equals negative 18/5, 6/5. And that's the answer to number 2. All right, let's look at number 3. We're going to find the projection. We need V dot W, which is 12 plus negative 9, which is 3. And we need the magnitude of W, which is 4 plus 9, which is the square root of 13. So the projection of V onto W is 3 over 13 times the vector W, which is 2, negative 3, which equals 6 over 13, negative 9 over 13. And since these vectors were written with i's and j's, if you wanted to write them with i's and j's, it would be 613i minus 913j. Okay, that is how we find vector projections. Now we're going to write a vector as a sum of orthogonal vectors. So stick with me here. Okay, by vector addition, we can also write V as a sum of vectors W1, which is the projection of V onto W, and W2. So right under that, at the top of that page, we're going to write V as W1 plus W2. This is how you write V as a sum of orthogonal vectors. W1 and W2 are perpendicular. Look at your little picture over here. Okay, this is perpendicular. Here's W2 and here's W1. We're going to write V as this plus this. So remember that W1 is the projection of V onto W. So this is what we're going to do. Here's number 4. We've got V and we have W. We're going to rewrite V right here as the sum of 2 orthogonal vectors, W1 and W2. Well, look, W1 is the projection. So let's find that first. So W1 equals the projection of V onto W. So that equals the dot product. So if we find the dot product of these, V dot W equals 6 plus 18, which is 24. So that equals 24 over the magnitude of W is the square root of 9 plus 9. So that's going to be 18 times W, which is 3. So we can reduce 24 over 18 as 4/3. So that just becomes 4. Okay. Now, remember what we're trying to do. We're trying to rewrite V as W1 plus W2. So let's substitute in what we have. V is 2, 6, right here. W1 is 4, 4. That's what we found right here. And W2 is right there. So we need to find W2 by solving this. W2 is just going to be 2, 6 minus 4, 4, which is -2, 2. So we can rewrite V as 4, 4 plus -2, 2. That is what we're trying to do. Rewrite V as the sum of two orthogonal vectors. These vectors right here are perpendicular. If you find their dot products, you get -8 plus 8, you get a 0. Okay? They are perpendicular to each other. And we've rewritten V as the sum of two perpendicular or orthogonal vectors. So let's do number 5. We've got V and W. And we're going to rewrite V as the sum of two orthogonal vectors. So the first thing we're going to do is find the projection of V onto W. So we got to find the dot product, which is 5 times -5 plus 8 times 5. And then on the bottom is the square of the magnitude of W. So this is going to be 25 plus 25, and then squared, and then we multiply that by W. So when you do all of this work right here, you should get 15 over 50. And when you multiply that through, you get -3/2 and +3/2. So remember what we're trying to do. Rewrite V as W1 plus W2. And this right here is W1. So let's substitute in what we have. 5, 8 equals -3/2, 3/2 plus W2. So we're going to solve this. And you're going to get your fractions on. This will be 10 over 2, and this will be 16 over 2. So 10/2 minus -3/2 is 13/2, and 16/2 minus 3/2 is 13/2. Look at that, it's the same. So we can rewrite V as -3/2, 3/2 plus 13/2, 13/2. And that is what we tried to do. We're rewriting V as the sum of two orthogonal vectors. These two vectors right here are perpendicular. Okay, let's look at number 6. We got 2 more. We got V is 2J and W is 8I minus 6J. So we're going to rewrite this as the sum of two orthogonal vectors. So we're going to start with the projection. We're going to find the dot product. So that's going to be 0 times 8, because there's no I here, plus 2 times -6. And then we got 8 squared plus -6 squared. And we're going to square all that, and we're going to multiply it times that vector. And when you do that, you should get -12 over 100 times 8 -6. And when you do that, you should get -24 over 25 and 18 over 25. So we're going to rewrite V as W1 plus W2. V is 0, 2. W1 is this. And then we're going to solve for W2. And your W2 should be 0, 2 minus -24 25ths, 18 25ths. So W2 should be 0, 24 25ths, 32 25ths. And we can rewrite V as these two perpendicular vectors, as the sum of these two perpendicular vectors. See if I can fit it in here. Okay, that's what we're trying to do. So the very last one now, number 7. We've got V equals 8I plus 5J, and W is -I plus 2J. Let's find the projection. And that's going to be 8 times -1 plus 5 times 2 over the square root of 1 plus 4 squared times -1, 2. W right there. And that becomes 2/5 times W, which is -2/5, 4/5. And then we're going to rewrite V as that plus W2. I was going to write V here as 8, 5. So we're going to solve for W2, which is going to be 8, 5 minus -2/5, 4/5. And that is 42/5, 21/5. Look at what fun numbers these are. So our V can be written as -2/5, 4/5 plus 42/5, 21/5. And that's what we did there. We rewrote V as the sum of two orthogonal vectors. Okay, we're only going to do, this is part 1 of this lesson. I'm going to do another video with part 2.